Good morning all. Now I am going to explain about some more questions on transformers. Okay, 74th question. A transformer has leakage impedance of ZE is equals to R suffix E plus J into X suffix E. Its maximum voltage regulation occurs at a power factor of. Okay, always maximum regulation occurs at lagging load, that is power factor cos pi is equals to, that means here what power factor, right? He is asking cos pi is equals to, in case of lagging load, power factor will be R by Z, that is R by Z lagging. Okay, from the given options second answer is correct. Next, 75th question. A transformer has leakage impedance of Z suffix E is equals to R suffix E plus J into X suffix E. Zero voltage regulation for this transformers occurs at a power factor of. Always zero regulation occurs at leading load. Okay, zero and negative regulation occurs at leading load. That means here zero, right? Zero means leading load. Okay, for this leading load, the power factor will be cos pi is equals to X by R. Okay, that is, wait a minute. Okay, that is 75th question answer will be for leading, that is X by Z. Okay, that is X by Z value here. 75th question option is third option, right? X by Z leading. Next, 76th question. A single phase transformer has a per unit leakage impedance of 0.02 plus J 0.04. Its regulation at power factor 0.8 lagging and 0.8 leading respectively. Okay, here what is given? Per unit impedance is given. That means per unit impedance can be written as per unit resistance plus J into per unit reactance, right? Okay, by knowing this per unit resistance and per unit reactance, the voltage regulation formula will be per unit resistance into cos pi plus or minus per unit reactance into sin phi. Okay, now see here, plus for lagging, minus for leading. Okay, what is given? Cos pi is given, right, in the problem. Power factor is cos pi is 0.8. If cos pi is 0.8, indirectly sin phi value will be 0.6. Okay, then voltage regulation for lagging power factor is 0.02 into power factor is 0.8, right? That is 0.02 into 0.8 plus 0.04 into 0.6. Okay, if I simplify that equation, for lagging load, voltage regulation is 4%. Similarly, for leading load, voltage regulation 0.02 into 0.8 minus 0.04 into 0.6, right? That is 1.6 minus 2.4. Okay, that value will be minus 0.8%. That means the voltage regulations are 4% comma minus 0.8% respectively. That means 76th question answer will be B is correct. Okay, before going to next problem, I can give one more important curve, that is voltage regulation curve. Okay, this is the important voltage regulation curve. This is applicable for both transformer, synchronous machine. Okay, every machine this curve is applicable. That means from this voltage regulation curve at least you will get a one question. Now see here, from the curve, center point will be 1 unity power factor. From center to right hand side, unity to lagging power factor. Okay, from center unity power factor to left hand side, leading power factor. Now observe the curve carefully. From 1 unity power factor to lagging side, voltage regulation is increases, right? That means voltage regulation increases at near to 0 lagging power factor, voltage regulation is maximum. That means from this curve, voltage regulation is positive at lagging load. Okay, and voltage regulation is maximum at lagging load. Similarly, now see here, from the unity power factor to left hand side curve, you will get here 0 is possibility at leading power factor side. That means 0 voltage regulation is possible at leading power factor side, and negative voltage regulation is also possible at leading power factor side. Okay, this is the voltage regulation curve. Sometimes you may get question like this: if the voltage regulation at 0.8 lagging power factor is 4%, what is the voltage regulation at 0.6 lagging power factor? Now see here, from this characteristics, from lagging side 0.8 to 0.6 voltage regulation is increases. Okay, that means answer is increases. In this way you will get a questions. Okay, that is about voltage regulation curve. Next, A 10 kVA, 400 by 200 volts single phase transformer with a percentage resistance of 3% and a percentage reactance of 6% is supplying a current of 50 amperes to a resistive load. The value of load voltage is, okay, the value of load voltage means the voltage regulation formula of a transformer is E2 minus V2 by E2. Okay, that means E2 is nothing but no load voltage, V2 is nothing but loaded voltage. That means we need to calculate loaded voltage V2. Okay, what is given? Percentage resistance is given, right, 3%, and percentage reactance is given 6%. I2 is given 50 amperes. Indirectly is given resistive load. When the load is resistive load, the power factor is unity. That means cos pi is equals to 1. Okay, cos pi is equals to 1 means indirectly sin phi is equals to 0. Then voltage regulation formula will be percentage r cos pi plus percentage x sin pi. Okay, that means sin pi value is 0, right? Then voltage regulation formula will be only percentage r into cos pi. Cos pi value is 1, that is 3% only. Okay, that means voltage regulation is 3%. Okay, that is E2 minus V2 by V2 is equals to 3%. That is E2 minus V2 is equals to 3% can be expressed as 3 by 100. Okay, from this equation, if I simplify this equation, V2 value as I am getting 194 volts is the answer. Okay, that means 77th answer 194 is the answer. That means first option is correct. Next, 78th question. In a transformer, RE2 plus JXE2 is equals to equivalent leakage impedance. Its maximum voltage regulation. Okay, already this point is discussed. Maximum voltage regulation is occurs at lagging power factor. Okay, maximum voltage regulation occurs at lagging power factor. That is, that power factor will be R by Z. That means see here from the given options, R by Z lagging, R by Z lagging. Okay, two times are present, right? Option A is R by Z lagging, option B is also R by Z lagging, right? But starting one term is given, right? Maximum voltage regulation occurs at percentage impedance only. That means first option is not correct, right? That means maximum voltage regulation occurs at impedance at R by Z lagging power factor. Okay, that means fourth option is correct. Next, 79th question. The full load voltage regulation of a power transformer is 0 when power factor of the load is near. Okay, what is given? Full load voltage regulation is 0. Okay, voltage regulation 0 is possible at leading load side, right? That means already we know about voltage regulation curve, right? See here, now you can observe this voltage regulation curve. Okay, 0 will occurs at from in between 0.8 leading to 1 unity power factor, right? That means near to 0.9 approximate leading. That means at leading load and unity power factor load, right, from the given options where it is present. 79th one, first one only, right? Unity and leading power factor load. That means 79th answer will be A. Next, 80th question. A 5 kVA, 250 by 125 volts single phase transformer has leakage impedance of 0.02 plus J 0.8 per unit. Its value in ohm refer to HV side. Okay, this type of problem already solved, right? What is Z per unit? Z ohm is equals to Z per unit into kV square by MVA. Already starting classes also this problem is same type of problem is solved. Okay, this 80th question answer will be B is correct. Next, the voltage regulation of a transformer is given by, okay, voltage regulation is nothing but no load voltage minus full load voltage by no load voltage. Okay, that is E2 minus V2 by E2. Okay, in case of alternator or alternators, voltage regulation formula will be E2 minus V2 by V2. Option A is correct in case of alternator, but in case of transformer, no load voltage minus full load voltage by no load voltage is the correct. That means second option is correct. 81st question. Next, 82nd question. The voltage regulation of a transformer at full load 0.8 power factor lagging is 4%. Okay, its voltage regulation at full load 0.8 leading power factor. Okay, after 0.9 approximately 0.9 the voltage regulation will be negative only, right? That means from the given options may be negative, that is based upon the load. Okay, next 83 question. The voltage regulation of a transformer depends on its, okay, voltage regulation is always depends upon, already we saw the formula. Voltage regulation is equals to percentage R cos pi plus percentage X sin pi, right? That means resistance, reactance and load power factor, that means as well as load current. Okay, that means 1 2 3, but that doesn't depends upon transformer size. That means 1 comma 2 comma 3 comma 5 are the correct. That means 83rd answer will be A is correct. Next 84th question. The voltage regulation of a transformer at full load and 0.8 lagging power factor is 2.5 percentage. The voltage regulation of at full load 0.8 power factor leading will be 0.8 power factor leading will be. From the voltage regulation curve, if we consider approximate value, that is minus 0.9 percentage, right? That means slight less than 2.5 only. That means third option is correct. Next 85th question, direct question. In synchronous test of two identical transformers having rated frequency, okay, third option, that is both the primaries should be fed from the voltage source at a frequency f, but regulating transformer may be fed at a different frequency. Okay, that is third option is correct. Next 86th question. The efficiency of a transformer at full load 0.8 power factor lagging is 90 percentage, full stop. Its efficiency at full load 0.8 power factor leading will be, okay, that is somewhat lesser than 90 percentage. But practically if we talk about that value, that is 90 percentage. Okay, if first option is not there, 90% is correct. Okay, that means that is doesn't depends upon either lagging or leading. Okay, but if somewhat slight lesser than 90% means, that means we need to give the priority to that one. Why? Because based upon that leading, slight change, very slight change. Okay, next 87th question. Transformer maximum efficiency for a constant load current occurs at, okay, maximum efficiency always occurs at unity power factor. Next, one transformer has a leakage impedance of 1 plus J4 and 3 plus J11 ohm for its primary and secondary windings respectively. This transformer has option A HV primary, option B medium voltage primary, option C LV primary, option D LV secondary. Now clearly observe the given impedances. Okay, primary side impedance is Z1, Z is equal Z1, primary side impedance is equal Z1 is equals to 1 plus J4. Secondary side impedance is Z2 is equals to 3 plus J4. When you compare primary impedance and secondary impedance, primary impedance is low. Okay, when primary impedance is low, primary current is more, right? When primary current is more, primary voltage is less. Why? Because transformer is a constant power device. Okay, transformer is a constant power device which transfer power from one circuit to another circuit by changing voltage levels and current levels, right? When current level is high, voltage level is low, right? When current level is low, voltage level is high. Now see here, from this question what is given? Primary side impedance is low means current is high. When current is high, primary side is low voltage. Indirectly secondary side will be high voltage. Okay, now from the given options, HV is primary, that is not correct. Medium voltage primary, that is not correct. No, that is not in a consideration. Third option, LV on primary, right? Primary side low impedance, high current, low voltage. That means 88th question, third option is correct. Next, transformer at no load behaves as a, under no load condition it behaves as a inductive reactor. The power factor, no load power factor will be approximately 0.2 lagging. That means from the given options, 89th one, B is correct. Next, 90th question. In a transformer, the tappings are provided on, okay, in case of transformer, always tappings are provided on HV side. Okay, why? Because on HV side the magnitude of current is low. That means if we provide the tappings, sparkings are less. Okay, that means from the given options, see here, HV side at one end of the winding. Next, LV side, that means that is not correct. Option C, HV side at middle, that is correct. Okay, always tappings are provided at middle of the line. That means HV side at the middle of the line. Fourth option is LV, that is not correct. That means 90th question answer will be C is correct. Next, 92nd first question. In transformer, the windings are tapped in the middle. The windings are tapped in the middle to eliminate axial forces. To eliminate axial forces. Next, 92nd question. In transformer, tappings are provided on the HV side. Already we discussed it. Tappings are provided on the HV side. Why? Because HV side, high voltage side, more larger number of turns, which allows smoother control of output voltage. That means first option is correct, right? Next, it has to handle low value of current. That means second option is also correct. Next, it is easily accessible for repairs. That is also correct. Fourth one, it requires less insulation. That is not correct. Insulation is depends upon voltage, right? High voltage side insulation will be more. That means 1, 2, 3 are correct. That means option D is correct. Okay, thank you all. Remaining we will see in next class.